We're going to solve this rational inequality, and this symbol right here makes it an inequality that less than or equal to. All right, equality would be equals. This is an inequality. And rational, if you look at the first part of that word, you will see ratio. And if you know me, you know that I call rational expressions big fractions. Now our answer for this is not just going to be one number, it's going to be a whole interval of numbers, or more than one interval of numbers. There's a lot of different answers here. And we're going to find out what would you plug in for x to make this less than or equal to 0. So we're going to find our boundary points, and our boundary points are going to come from here. It's going to be negative 12 would be one of our boundary points, positive 14 would be another boundary point, and negative 10 would be another boundary point. Okay, so these are the numbers that would make this binomial. If I plugged it in here, this binomial would be 0. All right, or if I plugged it in here, this binomial would be 0. Or if I plug this in here, this binomial would be 0. And it's very important at this point to note that if I am at negative 12, if this is 0, that is going to get a bracket because it is greater than or equal to 0. And at 14, if this binomial is 0, that is also going to get a bracket. But down here, this negative 10 is not going to get a bracket, because if you plug in that negative 10, you will get a 0 in the denominator, and that does not exist. That's not a real number. So we will have a bracket on the 12. We will have a bracket on the 14. But the 10 is going to get parentheses. So just keep that in mind for when we get to interval notation. So let's find our solution on this graph. I'm going to put down my boundary points. I have negative 12. Let me do this in blue. I have negative 12, and I have negative 10, and I have 14. Okay, making a note that negative 12 is less than negative 10, so it goes on the left of the number line. And the way that we're going to find what intervals are part of the solution and not is we need to pick test points. So I'm going to pick test points in between all of these boundary points. I'm going to pick back here, let's go for negative 14 maybe. Right here, the only integer is negative 11. And in this interval, I'll pick 0 because that's usually easiest to plug in. And then over here, let's go for 15. And if your test point comes out to be true and it is part of the solution, every other number in this interval will follow suit. It will also be true. If your test point is not part of the solution, every other number in this interval will not be part of the solution. Okay, so it doesn't matter whether I pick negative 14 or negative 13 or negative 13.5. If I get a true statement, everything in that interval will also give me a true statement. So let's go ahead and let's plug in these test points, and we're going to see which intervals are part of our solution and which intervals are not part of our solution. We have our 4 test points. First, for x, I'm going to plug in negative 14 everywhere I see an x. And let's evaluate this. So negative 14 plus 12, that is a negative 2, times negative 14 minus 14, that's a negative 28, over, looks like negative 4. And what's important here is whether or not you get a positive number or a negative number, because we need to know if it's greater than or less than 0. So I would get a positive 50 is at 56 over a negative 4, and my answer is going to be negative. So that will fit that it is less than or equal to 0. 56 divided by negative 4 gives me a negative 14. So this thing becomes negative 14. Is that less than or equal to 0? And the answer is yes. So negative 14 is a yes. And that means that everything on this interval will be shaded. All right, let's try negative 11. I'll put it right here, negative 11, and negative 11. Everywhere where I saw an x in my original. So let's see, negative 11 plus 12, that is 1. Negative 11 minus 14, that's negative 25. And in the denominator, negative 11 plus 10 is negative 1. Okay, so when I put all this together, I'm going to get negative 25 over negative 1 is going to give me a positive 25. If this is 25, is that less than or equal to 0? And the answer is no. Give them a color, so I will put no. So everything in this interval is not going to be part of my solution. Let's do 0. I'm going to plug in a 0. 0 plus 12 times 0 minus 14 over 0 plus 10. That is going to give me 12 times negative 14 over 10. Put that in the calculator. 12 times negative 14 divided by 10. And I'll get negative, I'll do a decimal, 16.8. All right, so when I plug in 0, this is negative 16.8. Is that less than or equal to 0? Is that less than or equal to 0? And the answer is yes. So this is also a yes, which means everything in this interval will be part of my answer. And let's do the last one. The last test point is 15, a positive 15. I'll put it everywhere I see an x. And I will get 15 plus 12. I think I can do that in my brain. That's 27. 15 minus 14 is 1 over 15 plus 10 is 25. And once again, the important thing here is it less than or equal to 0? And this is going to be a positive number, so the answer is no. I'll just leave it as a fraction. I'll get 27 over 25. 27 divided by, let's see, 27 divided by 25. I know my students like decimals. 1.08. Is 1.08 less than or equal to 0? And the answer is no. So this interval, nothing in this interval is part of my solution. Okay, so let's shade in the good parts, and then we will turn this into interval notation. So my graph, I'm going to use blue. If I have to pick the graph of the solution, it's everything in this interval, so everything from negative infinity all the way to negative 12. That's a yes. It's everything from negative 10 to 14 is included. And that's it, those two intervals. Now here's what's important. When do I use a parenthesis or a bracket? As I said earlier, negative 12 is going to get a bracket. Because at this spot, at negative 12, if I plug it in here, I will get a 0. The whole thing will be 0. 0 is less than or equal to 0. That is true. At 14, I will also get a bracket for the same reason. Okay, if I plug in a 14 for every x, I'll get 0. But if I plug in a negative 10, it gives me a 0 in the denominator, and that does not exist. So negative 10 gets a parenthesis. All right, so here's what my graph is going to look like. If you're looking for a multiple choice graph, you're looking for all this part in the blue. If you're going to do interval notation, let me get a nice bright color. Let's do green. If you're going to do interval notation, when I do interval notation, I like to I look right above the graph. I put it right below the graph. I have two intervals that are shaded. My first interval is negative infinity to negative 12. Parenthesis, infinity and negative infinity always get a parenthesis. Negative 12 gets a bracket. My next interval that's shaded is right here. It is everything from negative 10 to 14. Negative 10 gets a parenthesis like above, and 14 gets a bracket. And when we have multiple intervals in our solution, we're going to put a U in between them. That stands for union. And here is our answer. Interval notation. Okay, noting that if you plug in any number in this interval for x, here, here, and here, you will get a true statement. If you plug in any number in this interval in for x, here, here, and here, you will get a true statement. Any other number, not a true statement.